America's first radio-equipped control tower was established in 1930 at Cleveland Municipal Airport. The ability to transmit instructions by voice represented the most significant leap forward in air traffic control until the integration of radar nearly 2 decades later. Today, just as radar's limitations are constraining efficiency in the national airspace system, so too are voice communications beginning to show their age. Crowded frequencies, increasingly complex clearances, and the volume of controller-pilot communications can lead to misunderstood instructions and contribute to delays. Enter data communications, or Datacom, one of the 6 core transformational programs that comprise the Next Generation Air Transportation System, or NextGen. Datacom will enable controllers to send digital instructions and clearances to pilots as precise visual messages that appear on a cockpit display and can interact with an aircraft's flight computer. The benefits provided by Datacom will be numerous and significant.
For the equipped aircraft operator, data communications will contribute to improved on-time performance and schedule integrity, to reduce delays associated with avoiding weather or congestion on the air or ground, as well as increased aircraft efficiency through the use of services such as optimized profile descents.
U.S. Deputy Transportation Secretary John Porcari recently got a first-hand look at the potential benefits of Datacom during a simulation at the Department of Transportation's Washington, D.C. headquarters. In the simulation, Porcari, playing the part of an American Airlines pilot departing Fort Lauderdale for LaGuardia, struggles to copy down a complex revised departure clearance provided by former FAA controller Ron Boyd.
All right, 2092, I have your reroute. Are you ready to copy?
Ready.
All right, American 2092, you're now equipped with LaGuardia via the Zappa Transition, Valley, Direct Permit, Atlantic Route 16, Wilmington, Jet 48 Tar River, Direct Hopewell, Jet 191 Patuxent, the Corey 3 arrival into LaGuardia. Maintain 3000, expect 410 and 10, departures 126.05, squawk 2336, over.
And he was being nice.
American 2092 Zappa transition to Valley. I did not copy after that.
Porcari eventually got it, but only after precious minutes were lost as he and Boyd went back and forth repeating the clearance. Multiply those lost minutes by the number of aircraft waiting in line to take off, each one burning fuel and releasing carbon, and you'll start to get an idea of how today's voice communications can contribute to airspace system inefficiency. Now let's take a look at how that same clearance would be delivered by a Datacom. The controller calls up the clearance on the screen and sends it to the aircraft. In the cockpit, the pilot sees a new instruction that appears in bold at the top of the display. The pilot presses a button, and the detailed clearance is displayed on the screen. After reviewing the clearance, the pilot presses the Will Comply button, signifying acceptance, and the information is automatically entered into the aircraft's computerized flight management system. The Deputy Secretary was impressed.
We should compare that to those notes over on that page.
I'll take this.
The Datacom program is expected to reach a final investment decision in 2012 that will enable the agency to contract for the VHF radio network over which Datacom messages will be carried. Initial Datacom capabilities, such as departure clearances with revisions, are expected to start showing up at airport towers by 2015. En route center services, such as automated frequency handoffs and ATC clearances, are expected to follow a couple of years later. To ensure that all of the technical details are hammered out in time, a Datacom lab has been created at the FAA's William J. Hughes Technical Center in Atlantic City, New Jersey. The lab provides a testbed for the validation of standards and equipment, including Datacom's international compatibility.
Additionally, the prototype lab will also have another objective, and that is to provide for demonstrations, end-to-end system-type demonstration, whether they be in a lab environment or in an aircraft environment.
Human-in-the-loop testing at the Tech Center, meanwhile, is providing researchers with critical information regarding the design of the Datacom interface. Air traffic controllers taking part in these simulations have demonstrated an ability to comfortably handle increased traffic loads using data communications. There are many other advantages Datacom has over voice communications. Datacom messages are sent only to the aircraft for which they are intended, while voice communications are heard by every aircraft in the sector. Sent messages are stored for quick and easy review and can even be printed out to ensure the pilot and co-pilot are in complete agreement. By automating the delivery of routine clearances, Datacom will free up controllers to provide additional services for pilots, such as more direct routes and preferred altitudes.
Now, voice communications will always be a part of air traffic control. In fact, in critical situations, voice will continue to be the primary form of controller-pilot interaction.
But as NextGen continues to transform the national airspace system, Datacom will reduce the potential for error while playing a pivotal role in meeting the goals of increased capacity, fewer delays, reduced fuel burn, and lower carbon emissions. For more information on Datacom and other NextGen programs, visit the NextGen website at www.faa.gov/nextgen. From the William J. Hughes Technical Center in Atlantic City, New Jersey, I'm Bill Gordon.